So here is the final completed bicycle from about a 4-month project, and it is a carbon fiber bicycle. There are a set of 3 videos, I believe, that precede this. This video will just explain sort of some of the smaller intricacies that went into building the frame. As a general overview, the bicycle has a slight sloping geometry and as seen weighs about 19 pounds. Here we can take a closer look at the tubes, and you can see the spiral nature of the windings on the outer layer. There are gaps in the windings, which is a byproduct of me doing it by hand, it not being the most accurate. It's probably most evident on the down tube. There are some quite large gaps, probably equal to a fiber width in the way. These here, now that I'm here, are the bottle cage mounts. They're actually studs instead of bolts, so that the tube doesn't have a hole in it, just for a little bit extra strength. Similar principle up here with the bosses for the front gear selectors. The fork, thankfully, was a Bort fork, so no stress problems were expected there. The head tube that was shown in the frame jig video is simply buried underneath a little bit of carbon. One of the interesting things about the filament winding is how accurate you can get some things like the rear brake bridge. The brake bridge itself is simply a cut section of seat stay that was a bit extra that's glued in there and then overlaid with a whole bunch of more carbon, which I think is probably one of the more attractive pieces of the bicycle. At the rear dropouts, I decided to make the dropouts rearward facing, as you guys probably noticed in the frame jig video, but of course I wanted a derailleur bicycle, so the derailleur hanger mount here hangs a little bit down and is removable in case it gets bent. Here's another closer look too at how these tubes were joined. This aluminum of the dropout goes into the center of the tube, and then the tube is a bit tapered, filled with chopped fiber, and then overwrapped. It's probably not the lightest, but for the tools and equipment I had available, it was probably the best decision. Same thing is done here with the chainstays. But of course the chainstays were balsa wood cord. Since they're not round, I couldn't use the tube lathe method that was described in the WOMI video, and instead used a piece of balsa wood to wrap the fiber over. You can see the lines from where the compression tape held the fiber in place while it cured. Another little known aspect that of course you realize in the last weeks or so of the project is that you need cable fittings to be put in places. This cable fitting is actually a steel cable fitting that is at first tacked on with a small amount of epoxy and then covered in chopped fiber, which is why it looks rough to the appearance. It of course wasn't cleaned up at all. It could look much prettier with a little bit of preparation, but testing it was more important. All the tube joins, and especially this one here at the seat post, were done by simply tacking the tubes in place and then overwrapping with carbon fiber and one layer of fiberglass. Same thing at the front and at the bottom bracket, which was probably the most complicated joining section to do. You can see there also is a little chainstay bridge in there as well, and the cable guides screwed in at the bottom. That screw actually goes into the aluminum of the bottom bracket shell casing. Of the trickier frame elements to sort out is the mount for a braze-on front derailleur. I wanted to use a braze-on derailleur for the reason that the seat tube is a non-standard external diameter, and so finding a clamp-on that will work there will be very tricky. Also, I wasn't sure about the crush strength of the tube in that area, and so braze-on looked like the best answer. Now, to make sure the positioning was correct, I made this little jig. So let's take a closer look at this little jig. The jig bolts into the bottom bracket here using the same principle as the frame jig did. A piece of threaded rod, the 1mm spacer, and the taper. This little spike points to the rear wheel, and this mount secures the braze-on mount itself that you're going to be putting into the frame. Now this jig needed to be calibrated, so what I did was took this jig and put it onto a frame that I knew was straight and that had a braze-on front derailleur. I then mounted it, pointed this to the rear wheel, clamped that into the derailleur mount and tightened it onto the bottom bracket, made sure it was all calibrated, then removed it and put it directly onto the carbon frame, mounted a different derailleur mount of course, and then tacked it on with some epoxy. Once that was cured, this could be removed and then more epoxy could be added to the mount to get it as you see it on the bicycle now. Now you might be wondering why this wire sticking out the back is required, and it's for something that they refer to as derailleur angle, front derailleur mounting angle, and it's basically where you put the derailleur in this direction. It could be spaced perfectly left and right, but now spacing rotationally around the bottom bracket becomes crucial, and there are standards. I believe Shimano quotes a road and a mountain bike standard, and it bases itself on bottom bracket drop and seat tube angle, which of course moves this whole section around and moves the front derailleur mount forward and aft. If you have a very steep seat post, the front derailleur mounts more forward than it needs to be, so then it actually needs to be mounted farther back on the tube. Same thing with a lower bottom bracket, as seen on road bikes. The rear wheel is higher relative to the bottom bracket, so the front derailleur mount needs to be moved forward to get it correct. That's the reasoning why I just wanted to steal the geometry off a built bike that I knew worked, just because there's a lot of intricacies you can get into there. How it is now, this bike only works with one type of front derailleur. Putting on a generic Shimano one didn't work, hence why it doesn't run with one at the moment. It's because I'm still trying to find a Shimano one that'll fit. The problem the bike is currently running into with front derailleurs is that the tube is just simply too big and there's no space for the mechanism to retract far enough. It hits the tube first. I tried one Kempeg front derailleur which was offset very far back and then staggered back forward to the plates, and so the mechanism actually sits nicely behind the tube. And that's about it for this bicycle project. Hopefully I'll get some footage of me riding it so you can see some of the flexure problems it has as well. It's not ideal, but it's working pretty well for what it cost at least. It's very good. So thank you for watching, and please like and subscribe, because that's what people do on YouTube.